Okay, the next form is we call linear differential equation. That differential equation should be in this form, okay, where px and qx is a function of x or constant. Okay. So in order to find the solution of this one, we do this way. We try to find an integrating factor. Okay. So we got to arrange this differential equation rearrange it into the form of m dx plus n dy equal to 0. So in order to do this, we just multiply the equation by dx, right? So we would get equal to qx dx. We put dx and dx together. In order to get m dx, we would get px y minus qx dx plus dy equal to 0. Right. Now our m is pxy minus qx, and our n is equal to 1. We do derivative of m by y and derivative of n by x. Derivative of m by y equal to px. Derivative of n by x equal to 0. It's not exact. It's not an exact equation. So we want to find integrating factor. We think that 1 over n times the difference between dm by dy minus dn by dx got to be a function of x. So n is equal to 1, then I wouldn't write anything down, right? Because 1 over 1 is equal to 1. dn by y is equal to px, and dn by x is equal to 0. px minus 0 is equal to px, which is a function of x. So in that case, then, we would say that an integrating factor is equal to exponential of integral px dx. Now, we multiply this equation. We multiply equation 1 by integrating factor. We would get dx. And I said that on the left hand side of differential equation, it's equal to d of integrating factor times y equal to integrating factor times qx dx. We do integral of both sides. We would get plus c. Integral du equal to u, integral dx is equal to x. So integral of c mu y equal to mu y. Integrating factor times y. So we would get y is equal to 1 over integrating factor times the whole thing of integral of integrating factor times qx dx plus c. That is the solution. So when you have linear differential equation, you can use this formula to find the answer of that differential equation. But you need to define what is your integrating factor and what is your qx. And then you just plug it into this equation and then you'll be able to find the solution. Okay. Let's take a look at the example. Do we have time to do the example? Find the solution of dy by dx minus 2 over x times y equal to x. So from this, what is our px? Our px is equal to minus 2 over x, and our qx is equal to x. So you just plug the value in. You know that your integrating factor is equal to exponential of integral px dx, which is equal to integral minus 2 over x dx, which is equal to 1 over x squared. Then you just plug the integrating factor and qx into this formula. You would get y is equal to 1 over x squared times the integral of 1 over x squared times your qx is equal to x. Right. You know your integrating factor is equal to 1 over x squared. You just plug it in there, you would get 1 over x squared times the whole thing times integral of integrating factor, which is 1 over x squared times qx. Your qx is equal to x dx plus c, which is equal to 1 over x squared is equal to x squared times integral 1 over x dx plus c, which is equal to x squared times integral 1 over x dx is equal to ln x plus c. But if you don't want to remember this formula, if you don't want to remember it, so if you do this way, that means you've got to remember that y is equal to 1 over integrating factor times the integral of integrating factor times qx dx plus c, right? But if you don't want to remember this, because you don't need to, you can do it like from the beginning, like you have dy by dx minus 2 over xy equal to x. You know that your integrating factor is exponential of px dx, and you know that your px is there. Remember, if you want to use the formula that integrating factor is equal to exponential of integral px dx, you've got to make the coefficient in front of dy by dx equal to 1. Okay, because this formula derived from this differential equation, which is the coefficient in front of dy by dx is equal to 1. Okay, this one you just keep in your mind. And then this makes that integrating factor is equal to 1 over x squared. And then the way that you do next, instead of putting this into the formula, you can do that. Multiply x squared to our differential equation. So we would get x squared times dy by dx minus 2x dy, y equal to 1 over x, right? And then you multiply the whole equation by dx, you would get x squared dy minus 2xy dx equal to 1 over x dx. Like I said in the beginning, that on your left hand side, it would be equal to differential of integrating factor times y. Now you've got to check whether it is equal to the differential of integrating factor times y. You do differential of this one, you would get 1 over multiplied by 1 over x squared. Okay, I'm sorry. Because integrating factor is 1 over x squared, so you multiply it with 1 over x squared. 1 over x squared, so you would get right? So you do differential of this one. This one, if you do differential, it would be equal to 1 over x squared dy plus y d 1 over x squared, right? Right? If you differential of this one, right? ถูกไหมคะหน้าดิฟหลังบวกหลังดิฟหน้าSo this one is this one, right? Exactly the same. And this one, you do differential of 1 over x squared, you would get minus 2, right? Which is the same as this one. So that's why when you come up with this point, if your integrating factor is correct, okay? So under this condition, if you can find the correct integrating factor, you would know that this term would be equal to differential of integrating factor times your dependent variable. So I would say that then I would get the 1 over x squared times y is equal to 1 over x dx. And then you do integral for both sides. So you would get 1 over x squared y equal to ln x plus 3. So your y is equal to x squared times ln x plus 3, which is the same as when you use the formula. So it is up to you. If you don't want to remember it, you can start deriving from that.